When we did this last class, it was all very straightforward to like add and subtract or multiply and divide numbers. We got cosine by itself, and then we said, where is cosine equal to that? Also, by the way, if you would like one of those little charts out next to you, you are more than welcome to have whatever one that you have made out next to you. On question 1, it's a little bit less straightforward, solving for the trig function sine, because I have a sine squared and a sine in it, right? So what actually applies to this as well is normal factoring, like trinomial factoring. Back in the fall, we spent a lot of time factoring things that looked like this, okay? This is actually the very same factoring, although there's signs in there in place of the x's. So if I was to factor this, I am going to use my same guess and check method of factoring that we used in the fall. If I see a 2 sine squared, what is that going to split into? 2 sine and 1 sine. You don't really have to put the 1, but that's kind of what we're thinking. Then I see the plus 1 at the end. The plus means that we have 2 negative signs, and my only factors of 1 are 1 and 1. So it has to be minus 1 and minus 1. How do you check if this has actually worked? Yeah, you can like check the outer terms and the inner terms here. That gives me negative 2 sine x, and this gives me negative 1 sine x. Does that add up in the middle to negative 3 sine x? Yes, it does. Okay, so now let's remember, what do we do with our factors once we are in factored form to solve? Set them equal to 0, and here is where it's going to look exactly like what we did last class. I now have 2 different things. 2 sine x minus 1 equals 0, and sine x minus 1 equals 0. It's kind of like we're solving 2 different problems at this point in time, but we're just going to say all of these answers apply to this one question. So the first one, let's just worry about the first one first. If I want to get sine by itself, what do I have to do? Add 1 and divide by 2. So this piece is asking me, where is sine equal to what? 1/2. The other piece is going to be asking me, where is sine equal to 1? We're just going to lump all of those answers together, okay? So let's first worry about where is sine equal to 1/2. So using our chart, where is one place that sine equals 1/2? Sure, pi over 6. Sine is also positive in what other quadrant? Second quadrant. Okay, so what's the pi over 6 angle in quadrant 2? 5 pi over 6, yes. So that's my second answer for where sine is 1/2. Okay. Is that all I should expect out of sine equaling 1/2? Yes, because there's no plus or minus. I don't need the places where it's negative 1/2, right? So now let's move on and worry about where sine is equal to 1. Is there a place in our chart where sine is equal to 1? Pi over 2, okay? Will it also be 1 at 3 pi over 2? No. Why not? What is it at 3 pi over 2? Negative 1. So there are places that you will get only one answer for that kind of equation. And then you'll also get different answers for this one and have 2 answers there. So remember last class we said all of our answers should have the same denominator. Okay? This is where that goes out the window, and it's because there's kind of 2 different things we're finding answers to. And they're all included in our final answers. So there's not necessarily going to be any rhyme or reason to how many answers you should have. It's just sometimes there's going to be 2, sometimes there's going to be 1, sometimes when you combine them all together, there's going to be 3 answers like this. I just need all the places between 0 to 2 pi that this happens. Okay? Questions on 1? All right. Now, let's take a look at question 2. In question 2, I have something that looks very ugly right now. 2 sine x cosine x is equal to root 2 cosine x. We did regular trinomial factoring in question 1. And it was already equal to 0. Because in order to factor and solve, your whole thing must equal 0, which means, what do I have to do first in question 2?
Set it equal to 0.
Set it equal to 0, which means I need to take this entire thing here and move it to the left. How do I move it to the left? Subtract. please do not divide by cosine there. I know it is very tempting to divide by cosine right there. If you divide by cosine, it's the same as in the fall when we said you can't divide by x. You lose answers. If you divide the cosine out, you lose all of the answers for cosine that we would have had, and you're only really going to get half credit on the question because you've missed out on all those answers. You've canceled them out for yourself. Instead of canceling them out by dividing, we're going to subtract that to the left side. What other kind of factoring have we done this year? Greatest common factors? Do I have a greatest common factor here? Okay, I can't take a root 2. I have a 2 and a root 2 separate. What else do I have? Cosine. Cosine is my greatest common factor. I'm going to pull that out. If I pull that out, what am I going to be left with? 2 sine x minus root 2. Are we in the place now that if we set our two factors equal to 0 that we could solve each of them for a single trig function? Yes. So we'll take cosine and we will set it equal to 0. And we'll be looking for where is cosine equal to 0. We can get answers from our chart. If we take this whole parentheses here and set it equal to 0, what am I going to do to solve this one? Add root 2 and divide by 2. So this one is going to be looking for where is sine equal to root 2 over 2. When we solve these things, it generally, not all the time, we're going to see one in a minute, but a lot of these should be like, oh yeah, I recognize that number from my chart. Perfect. So from here, we're looking for two different things. Where is cosine equal to 0? Or, okay, and I'll make a note here. This is an or situation. An or situation means write down both sets of answers, call them all your answers. On the previous homework, we had and. And was it has to be true at the same time. This is this one or this one, write down all your answers. So take a minute using your chart, okay, and write down all the places you get for where cosine equals 0 or sine equals root 2 over 2. You need 4 answers to end this question. Cosine's equal to 0 at pi over 2, which means where is the other place that cosine is equal to 0? 3 pi over 2. Okay, that 0 can't change from positives to negatives, so it stays 0 at both pi over 2 and 3 pi over 2. All right, what about sine equaling root 2 over 2? Where's the first place? Pi over 4. Sine is also positive at 3 pi over 4. I do not include the places where sine is negative, so I just leave those 4. How do we feel about our answers? Good? Where would what be negative? All right, so now at this point, you know how to solve by trinomial factoring. We've done this in question 1. We should recognize the same thing in question 3, okay? 3 does have something interesting in it as well, though. Okay, so we're going to chat about it in a minute. Okay, I'd like you to get to the place where you know cosine equals this or cosine equals this, and then we'll talk. Okay? And you'll see why we have to talk about that when you get to that place. I then know I am looking for where is cosine equal to, what's the first thing? -5, or where is cosine equal to -1? Which one of those seems a little bit odd to us? Yeah, why does that seem odd? Yeah, we've never seen anything like that. Usually, like, it starts working out and you're like, oh yeah, root 2 over 2 or root 3 over 2. Okay, so this is where one last part of our semester so far ties back together. Remember with me the graphs. What did the cosine graph look like? There's a reason. It started at a maximum and it went like this, yes? What was the highest point on that? 1, and what was the lowest point? -1. So what does that tell us about that? Does cosine ever equal -5? It does not, okay? What do we do with answers where we say it's never going to equal that? Ignore it, okay? But like if it comes up on a quiz or a test where you have factored and you can't get answers from one part of it, is that now going to be weird to us? And you're going to be like, Miss Leininger, what did I do wrong? No. We're going to have answers that don't work. This does not mean the whole question is no solution. What do I worry about? Yeah, just where's cosine equal to -1? I can still get an answer from this. Do we see anywhere in our chart that cosine's equal to -1?
Pi.
We know it's at pi because at 0 it's 1, and on the left-hand side it is negative. So this question has only one answer to the whole stinking thing. Do all that work for that. It's lovely, isn't it? But occasionally we will get to answers that we cannot do. Okay?
That's great.
All right. Take a look at question 4 and see where you can start off with. Once I pull out the cotangent squared, what am I now left with? 1 minus cosine squared. Now, I have about 3 different ways that I could go from here. Is this factored enough to set your factors equal to 0 and solve them? Yeah. Yeah, because I can say where is cotangent squared equal to 0? And this would be like what we did on our homework last night. 1 minus cosine squared is equal to 0. I can add the cosine squared to the other side and square root. If you don't like the 1 minus cosine squared, what's my other option with that? I can change it to sine squared. Which one are we more comfortable with? Sine squared? Sure. All right, so if we change that then to sine squared, which is totally fine, I am still in a good place here that I can set my 2 factors equal to 0. Now, on both of these, how am I going to get rid of the squared? Square root. Do I need to worry about a plus or minus when I'm square rooting 0? No. So cotangent equals 0 and sine equals 0. Which one do I still have to change a little bit? Cotangent, because I never do cotangent, cosecant, and secant. I switch them. Now, quick question. If I do the reciprocal of cotangent, it becomes what? Tangent. What is the reciprocal of 0? Undefined. Okay? 0 you get from it being 0 over 1. If I flip it upside down, it becomes 1 over 0. This is how I get undefined. Okay? So now I'm looking for 2 different things. Where is tangent undefined? And where is sine equal to 0? How many answers should I maybe expect from this? 2 from each. Yep. So a couple things about this. First off, where's one place that tangent is undefined? Pi over 2, which means it's also undefined where? 3 pi over 2. Okay, they're going to go in pairs with reference angles. Those 2 are my tangents undefined. What about where sine is equal to 0? 0, which means the other place will be pi. You do not need to include 2 pi. Okay? 2 pi is a repetition of 0. Because remember, we get back around and 2 pi, we've landed in the same spot as 0. So it's like saying the same answer twice. It's not wrong, but it doesn't need to be included. Okay? If you had solved out the cosine, just to be clear on that one, 1 minus cosine squared can factor as a difference of squared. Difference of squares. 1 plus cosine, 1 minus cosine. Therefore, you are then looking for where is cosine equal to plus or minus 1. Cosine's equal to positive 1 at 0. Cosine's equal to negative 1 at pi. So whether you change it out for sine squared and look for where sine is equal to 0, or you don't change it out and solve for the cosines, you are going to get the same answers. Now, here's where I'm really going to tell you to pay attention. If you know, because there are some of you that really struggle with the cosine being negative 1. Like, it's always that one that you don't like. Cosine being negative 1 or cosine being positive 1. If you know about yourself that this kind is going to be a problem, then stick with the other one. Like, you have methods, just choose which ones you're more likely to get the right answers for. Like, if you're thinking to yourself, well, I can find where sine equals 0, but I really struggle with the cosine being positive and negative 1, then try to stick with sine equaling 0. It's not always going to work, but when you have the choice, go with the 0 one, okay? You can save yourself a lot of work on that, okay?
Wait, why would it be
Just some people with the -1 struggle with where it's going to be -1 because it's not in a quadrant.
How do you know it's
Cosine is -1 over at pi because it's the same as the reference angle at 0. But it's still negative because cosine's negative in quadrant 2 and 3, so it stays negative the whole way.
So I can't think about it like if you just have as x equals 1, it's just your 2. Since 0 is one of your answers, pi is one of your other answers.
If it's plus or minus, it works that way, but if it's not plus or minus, it's not.
If it's just normal,
Yeah.
if it's just positive 1, the answer
Then
is
it's only
always
one answer, yeah. That's what the problem with that. Out of everything we've done so far, we are now going to be adding identities back in. And so this is where we're going to see a small amount. This is not major proofs. This is not 5-step anything, okay? In a question like number 1, we, on the previous page, factored these things kind of like a trinomial. Why can I not factor this right now? It's not equal to 0. That's problem number 1. Problem number 2, the squared term is a sine, and the not squared term is a cosine. So it would not work as it stands. So I need to change one of those out. Is it easier to change a single cosine, or is it easier to change a sine squared?
Sine squared.
Okay, so according to what we learned in proofs, what is the same as sine squared? All right, so if I take out my sine squared and in place of it, put 1 minus cosine squared, will this look a little bit more like the ones on the previous page now? I have to do a little distribution and a little bit of movement around, but this turns it right back into a normal factoring question. I would quickly distribute my 2 and then move everything to the left so it equals 0. So I would have 3 cosine x plus 3 is equal to 2 minus 2 cosine squared. I move everything to the left because I don't like to factor with the negative cosine squared term. I'd rather that be positive, so we're going to scoot that over to the left. Leave the 3 cosine x, and when I subtract 2 from both sides, I get plus 1. Is this question now any different than the ones we did on the previous page? No. So take a minute. This will be the last thing we do before lunch. Factor and solve. All right, so if we're looking for where cosine equals 0, that part of it's pretty straightforward. Where is cosine equal to 0? Pi over 2, which means also 3 pi over 2. So those two for cosine equaling 0. If I have to go about solving this, root 2 minus 1 over sine x equals 0. What's the best way for me to solve this? Add the 1 over sine to the other side. And then what is the easiest way to go from there? Yeah, just flip both sides. If I flip the right side, it becomes sine. If I flip the left side, what does it become? 1 over root 2, which we don't recognize, but we just talked about on the last homework. What do we mentally do? Multiply by root 2 over root 2, top and bottom, and this makes it, where is sine equal to? Root 2 over 2. All right, so 2 places for that. Where's one place? Sine equals root 2 over 2. Pi over 4. And the other place sine is positive root 2 over 2 is 3 pi over 4. So 4 total answers there. Any questions on that one? All right, let's take a look at 3. 3 is a little bit different. Sine x minus cosine x. Do I have a greatest common factor? No. No. Does this factor like a trinomial? No. Can I switch out sine or cosine? No. Not individually, sine and cosine. Okay? So it may feel like we are stuck. However, if I move the cosine to the other side, what is this then asking me? Where are sine and cosine equal? Take a minute. There's 2 places. 5 pi over 4. Okay, so I've got pi over 4. 5 pi over 4 is where they are also both root 2 over 2, but they are both negative because we're in third quadrant. All right, one more identity one, and then we're going to hang out on the same type of topic for the rest of the notes, which will go pretty quickly. Question 4. Has cosine of 2x is equal to cosine x? Where have we seen cosine of 2x before? Yeah, our identity sheet. Okay, right now I don't like to have both a 2x and an x. As we'll see in just a minute, a 2x by itself, like in question 6 or in question 5, is totally fine. However, with a 2x and an x, I need to switch one of them out. It's always going to be easier to switch out the cosine of 2x. Now we had 3 options for cosine of 2x. One was cosine squared minus sine squared, bless you. One was 2 cosine squared minus 1, and one was 1 minus 2 sine squared. Which one do you think we should use? The cosine squared one, because it makes everything in terms of cosines. Which means, what should my next move be on question 4? Get everything to one side and make it equal 0. Proceed like we've been doing. See if you can finish this one out. Any issues with finding our answers on 4? All right, now, there is a difference between question 4 and question 5, 6, and a bunch of the other ones on the back there. These are going to go quickly. When we have a 2x by itself, I could switch this out for a double angle identity. What you will often find on some of these is it actually makes it harder and longer to find your answers. So what we can do on this one, if I just kind of mentally ignore the 2x, and I know we don't really like the theta symbol, but just follow with me for a second. What if I just said this was sine of 1 big theta? If it was sine of theta equals 0, could I solve that? Sure, I know where theta, or where that would be 0, right? Where is sine equal to 0? Add 0, where else? Pi, okay? But really, I put that big theta in place of what? 2x. So we solved for where sine is equal to 0. But what if I back it up a second and say, oh, wait now. Now let's say that theta wasn't there, and that is just 2x. That means I am one step from my final answer. What do I have to do to my answers to solve for x? Divide by 2. What is 0 divided by 2? 0, and what is pi divided by 2? Pi over 2. Now, that's not very hard to do, is it? We just kind of ignore the 2x for a minute, find where sine is equal to 0, and then divide by 2. The only issue with this is, essentially when we divide by 2, it takes our answer set and shrinks it down. So there are more places where sine could be equal to 0 in 0 to 2 pi, okay? The whole way through this conversation and the solving, we've been saying we don't really have to include 2 pi in our answers because it's a repetition of 0, right? And we talked back in like unit circle talk that we could literally just rotate around and around and around, and it could keep being more angles, right? So what we can do on this then is we can get more answers for ourselves by kind of following the pattern out. If 0 was an answer, what's the next answer? One full circle around from 0?
3, 6.
Okay, so 2 pi. So 0 repeated is 2 pi. What is pi repeated? If I went around one full rotation after pi, 3 pi. And I could keep going. 4 pi, 5 pi, 6 pi, so on, right? But I want all of my final answers to fit within 0 to 2 pi. So let's check if we have this enough now, because remember, we divided everything by 2. So these answers also have to be divided by 2. What is 2 pi divided by 2? Pi. Is that still within 0 to 2 pi? Yes. What about 3 pi divided by 2? 3 pi over 2. Now, what if I had kept going in the pattern? My next one would have been what?
4 pi.
4 pi. If I divide that by 2, I get what?
2 pi.
And we always said our final answers do not have to include 2 pi, right? So I do not have to keep going endlessly. I just want to get enough answers that I have all of the answers between 0 to 2 pi. Now, there's a rule of thumb for this, because I know we don't like just extending this out endlessly. Before we divide by 2, I find all of my answers that I get 0 to 2 pi. That's one rotation. Then I find the second rotation around the circle. Like I said, repeat of 0 is 2 pi, repeat of pi is 3 pi. This is my second rotation around the circle. If you are dividing by 2 out front, all you need to do is 2 rotations. If you're dividing by 3, you need to do 3 rotations. If If you're dividing by 4, it'd be 4 rotations. Now that seems like just extra work at that point. But at this point, we're just going to use like 2 and 3 maybe. Okay? So let's try that again with the one right next to it. Again, the same idea. We're just going to say, okay, that's like one big theta. Where is sine 1/2? Pi over 6. Where else is sine 1/2? 5 pi over 6. Are those the only 2 answers in our first loop around the circle? Yes. All right, now, remember that these aren't our final answers for x. These are our answers for 2x, right? So let's say now this time before we divide by 2, let's find our additional answers for ourselves before we divide by 2. If my first answer was at pi over 6, where is another answer going to be if I went a full rotation around from 5 pi or from 1 pi over 6? 13 pi over 6. How do we get that? Add 2 pi in terms of sixths. And that's going to be the rule of thumb. Add 2 pi every time. So then what's one more rotation around from 5 pi over 6 going to be? 17 pi over 6. Yeah? 2 pi in terms of 6 is 12 pi over 6. So that's what I'm adding every time. Now, let's look at what dividing by 2 does to our answers. Okay, because we don't like fractions that much. But really, what does dividing a fraction by 2 do? It multiplies what part of it by 2? The denominator. So my first answer is going to be pi over what? 12. Second answer? 5 pi over 12. Third answer? And 17 pi over 12. All of those answers fit within 0 to 2 pi because I know that 2 pi in terms of twelfths is 24 pi over 12. So all of those are less than 24 pi over 12. Okay? Let's see what this does for us going forward. Try this one. Question 7, same process, only it's tangent. So first thing we do is we ignore the 2x and we say make this one big theta and find where does tangent equal 1. Once I get my first 2 answers, I recognize that I'm going to divide by 2, so I need to add in an additional set of answers from those. What did we say we're adding every time to our answers?
2 pi.
Okay, what is 2 pi in terms of fourths?
9.
If I add it, it's going to be adding 8 pi over 4, right? So what's my next answer? 9 pi over 4, and then from 5 pi over 4, it becomes 13 pi over 4. And then our final step will be to do what to every answer? Multiply the bottom by 2. So I get pi over, everything's going to be basically over 8, right? Pi over 8, 5 pi over 8, 9 pi over 8, 13 pi over 8. Okay. Questions on that one? We're going to finish up with the last couple. 8 looks a little bit different. I have a sine x times a cosine x. Are we allowed to split it up if it's not equal to 0?
No.
No. Any other thoughts about what sine x, cosine x looks like? Do we recognize that from anything?
Multiply 2,
Ooh, why would I multiply by 2?
because then it would equal an identity.
Yes. If I multiply by a 2 right there, where have we seen 2 sine x, cosine x? What does that turn into?
Sine 2x.
Sine 2x. Now, if I multiply by 2 there, where else must I multiply by 2?
The other side.
The other side. Now, this becomes exactly like one of our ones we've just been doing. See if you can go to your final answer from here. Remember, pretending 2x is one big theta. Where is sine equal to -1 first? All right, so my initial answer is 3 pi over 2, and that's the only place 0 to 2 pi that sine equals -1. These are our answers for 2x, right? Before we divide by 2, what do? Find the second possibility by adding 2 pi in terms of halves, which is 4 pi over 2. That gives me what? 7 pi over 2. And then for our final answers, what do we do to these?
Times 2 by the bottom.
Times 2 by the bottom. So I get
3 pi over 4.
3 pi over 4, and 7 pi over 4. All right, our last two look slightly different. What's the only difference on our last two?
There's fractions.
There's fractions. Good news. You can pretend those are one big theta too. All right? So there's one good piece of information. If I pretend that's one big theta, this is asking me the question, where does sine equal root 3 over 2? All right, so let's answer that question first. Where does sine equal root 3 over 2? Pi over 3. Also, again, at 2 pi over 3. This time, these are my answers for what, though? Not 2x, x over 2. Okay, so remember I told you when it was a 2x, it kind of like it shrunk our set of answers so that we needed some extras. Because when we divided by 2, it shrinks them. What are we going to do this time to solve?
Oh.
Multiply by 2. So I am not going to need on this one to add any answers in, because rather than shrinking my answer set, this is actually going to take my answer set and make it expanded. What will happen on some of these is some of these answers, when you multiply by 2, will go past 2 pi. Okay, this one it does not, but we're going to see one in a minute. Okay, so don't add additional answers on when it's an x over 2. When it's 2x or 3x, do add additional answers. This time when I multiply by 2 times both sides, where am I going to multiply that to? To the top. So what does my first answer now become? And my second answer becomes, are those both within 0 to 2 pi still? Yes. Now, if one of those answers was further around the circle, it might send it right off past 2 pi, which we're going to see on our last one. So go ahead and try question 10, same way. That's our last question. There's your big theta, and see what you can find. Where does tangent equal root 3? Pi over 3, and again, where? 4 pi over 3. First quadrant and third quadrant. Remember, these are our answers for x over 2. What do I then do with that 2? Multiply. So my first answer becomes 2 pi over 3. My second answer becomes what? 8 pi over 3. What is the problem with 8 pi over 3?
It's
Bigger than 2 pi, which means I get rid of it. So when I multiply by 2, it often expands those out to the place that some of them are past 2 pi. The 2x is not, the x over 2 is. Okay?